Continuing lesson 29 with sequences and basic series. Now, a recursively defined sequence is exactly what recursively stands for, okay? I'm going to go ahead and read this to you, and then we'll go ahead and explain what it means. A recursively defined sequence is one in which each succeeding term of the sequence is defined by using some of the preceding terms. So, recursively defined means previously defined terms, okay? Again, I have it in here. We don't like this form. Sometimes it's the form we have to use, and sometimes it's the form we're given. So, let's talk about what this is. I'm going to go ahead and write 9a on my paper here, and we're going to go ahead and work through that. So 9a, it says let a1 be equal to 1. Let a sub n be equal to n a sub n minus 1. Now this is very important that you understand. I want you to find, again the question asks me to find a sub 2, a sub 3, and a sub 4. Now be very careful with recursively defined sequences. This is not, okay, this is not some n minus 1 multiplied by an a. No, this is a sub n minus 1. It is very similar to a sub n. The only difference is that if I look at a sub n, okay, now notice it's not asking me for a sub 1. It gave me a sub 1. I don't need to find that one, okay? What if I wanted to find a sub 2? Well, let me plug in 2 for all of my n's. This n will be replaced with a 2. And my a sub 2 minus 1. Well, what is a sub 2 minus 1? I can do the math in the sub notation. This 2 minus 1 is just a 1. So this is going to be 2 times a sub 1. What's a sub 1? They gave me that. That's why they gave it to me. Again, the next term is defined in some way by its previous term. The nth term is determined in some way by the nth minus 1 term. So this is going to be equal to 2 times 1, which is therefore 2. A sub 2 is simply 2. Okay? How would I find a sub 3? Well, again, in this formula, I'm going to replace all of my n's with 3. So, n here is 3, and this is a sub 3 minus 1, but 3 minus 1 is 2. Again, I can do the math in the sub notation. So, this is 3 times a sub 2. Well, what's a sub 2? A sub 2 is 2. So this is 3 times 2. That gives me 6. Now again, this doesn't seem like it's that difficult, possibly, but what if I asked you to find me a sub 20? Could you plug 20 into this formula? Well, sure. Okay, before I actually do this one, let me go ahead and identify what's happening here. A sub 20 is equal to 20 times a sub 20 minus 1 is equal to 20 times, what's a sub 19? And there's our problem. We would have to go through every single one of these steps until we get to a sub 19 before I can figure out a sub 20. This is why we don't like recursively defined sequences. They're nasty. They force us to use every single term. We can't just simply jump around certain numbers. So our goal here is to hopefully be able to find the first few terms and turn this into an nth term defined sequence. Again, similar to this sequence here in example 5a, or this example here, number 3, okay? That's what our goal would really be. Let's go ahead and find the fourth term. A sub 4 is going to be equal to 4, because my n here is going to be 4, and this is a sub 4 minus 1. A sub 4 minus 1 is going to be a sub 3, where 3 is going to be, back up here, 6, okay? Let me zoom this out just a little bit so you can see it all at once. Again, I'm looking for a sub 4, plug in 4 here, plug in 4 here, plug in 4 here, and get a sub 4 minus 1. 4 minus 1 is 3, a sub 3 is 6 from here. So I get 4 times 6, which is 24. And again, to help narrow this thing out, let's go ahead and write this in the notation that we like, is the first term, the second term, the third term, the fourth term, and this does continue on forever. Okay, this would be the ones I'm looking for. Now, you can, again, leave it like this. This is perfectly acceptable. I will accept this. But this is a lot easier to write, okay, and it'll save you a lot of room. If I wanted to know, okay, what the pattern here was. There's only one way to do it right now. Okay, there's not a comfortable way to work through this. I mean, you're legitimately multiplying this by 2, multiplying this by 3, multiplying this by 4, and so on and so forth. So it is difficult for us to define it any other way than this, for now. Okay, for now. But we will come back to that concept. Now, let's go ahead and look at number 10 and that definition. Now, if n is a positive integer, then n factorial, and that's how it's read, n factorial. Now, you can think of it, and I have to do this, n! Like, really excited about it, maybe not, who cares? The point is that when it's n factorial, it is legitimately the term n multiplied by every previous whole number before it. So, n times n minus 1 times n minus 2, so on and so forth, all the way down until you get down to 1, okay? With it also forced to be defined that 0 factorial is 1, okay? There are some things in mathematics that we just say, hey, this mathematically works the best for us, so this is how we're going to define it. 0 factorial is 1. Yes, it's unlikely and honestly very confusing, but this definition, don't forget it, okay? Let's go ahead and talk about example 11a. So example 11a asks us to simplify the factorial expression. Now, maybe it's hard to understand factorial, but again, think of it as this. 5! You're really excited about it, maybe not, who cares? What is 5 factorial? It is 5 and every whole number multiple before it, all multiplied together. So 5 times 4 times 3 times 2 times 1. What is that number? Well, this is going to be 20. This is going to be 6. That's still going to be 1. If I multiply all that together, I get 120. 5 factorial is a numerical value. It is 120. That's it. Okay? Let's look at 11b. 11b is 10 factorial. Now, I do not want to do this in my head because what is this again? 10! I know I keep yelling at you. I apologize. This is 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, and 1. I can barely fit it on the screen there. You have to multiply all these things out. Yes, you have to multiply all these things out. It becomes a very large number, but that's the concept, okay? I mean, this is going to be 10 times 9, 90, 9 times 80. I have no idea. Okay, it's too much work for me to do without a calculator, and I'm not looking for one. So, multiply all those out. You'll get a number. That's your number, okay? Again, if you're nervous about the number you might get, check it with me in class. Let's do 11c now. These are the real ones that are actually important. Okay, 11c is 8 factorial, divided by 5. Okay, so you have 8 factorial divided by 5 factorial. What is this really? Do not, please, 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 do not multiply all these out. Okay? Do not make it 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 and then multiply all those numbers and write it down. Do not write out 5 times 4 times 3 times 2 times 1 and then multiply them all out and then try and divide two obnoxiously large numbers. It's not pretty. It's not fun. There's an easier way. 1's cancel out. 2's cancel out. 3's cancel out. 4's cancel out. 5's cancel out. You're left with 8 times 7 times 6. Which, maybe, again, is still too large of a number for you to do, but it's a heck of a lot easier, okay, than multiplying all the numbers out on top, dividing by all the numbers on the bottom multiplied out, just to find out that they all cancel anyways, okay? Now, that number will be 336 if I did it correctly. Again, I'm going to do it one more time just to check. It's 8 times 7 times 6, and you get 336. That is the numerical value for that, okay? Again, keep in mind, when we're dividing two factorials, no, the factorials don't just cancel out. You write out the numbers until you understand that really, and I'm going to write it out here, 8 factorial is really 8 times 7 times 6 times a 5 factorial. And the 5 factorials are the same and they can cancel each other out. Notice, again, you're left with the same thing. Again, stick to this until you're comfortable with that concept. Last one is D. 11D is not fun. Only it's not fun because you're subtracting two factorials like this. No. No, no, no. This is not. Never will be, okay, 2 factorial. Doesn't work that way. These are two multiplicative pieces, okay? Let me show you what they really are. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1 minus 4 factorial is 4 times 3 times 2 times 1. Okay, I have to multiply first, right? Because order of operations says PEMDAS. Parentheses, exponents, multiplication, division at the same time, addition, subtraction at the same time. I do multiplication first and then subtraction. There's an easier way to do this. Again, I'm really lazy, and you guys know that. Isn't there a 1, a 2, a 3, and a 4 in both of these? Can I factor all that out? Let me do that. 4 times 3 times 2, that's 12 times 2 is 24. I'm going to factor out a 24 from this. Again, I'm going to factor this whole piece out and this whole piece out. That leaves me with 6 times 5 minus, what's this end up being? A 1. So this is 24 times, well, 6 times 5 is just 30. 30 minus 1 is just 29. Which, again, maybe you can't do those multiplications in your head, but that's a lot easier to play with in the long run. That number right there gives you 696. Okay, again, keep in mind that factoring is a possibility for these. Okay, we will go ahead and get into the summation notation in the last video, and that last video should be relatively short.